where is this?
At the library, Mass Library.
Oh, so we're off the mask mandate now?
Dane County is off the mask mandate now. But the campus, for inside campus buildings, that's tomorrow, that's when it starts.
Yeah, that's what I mean, the campus, when it's up. I know it's Dane County.
Yeah, campus is tomorrow itself. All right, we are up and running. Welcome to Weather Watch.
Pleasure to meet you. I'm Kim. Nice to meet you.
She's a sophomore. Yeah.
Excellent.
Good.
Excellent. Good.
They're both
Well done.
Yep.
Yes. Precisely.
Okay, welcome to Weather Watch. Next week we'll have a break during spring break, and then we'll resume Weather Watch 2 weeks from today. What we're going to talk about today will be briefly some interesting things about the impact of war on observations, very briefly. Also talk about the sort of seasonal outlook a little bit. Then we'll get into the current weather, talk about the passage of this front and trough that went by that gave us the snow showers earlier today, and then look ahead to the weather for the upcoming week. So this is a page taken from the Aviation Weather Center, and it's showing the distribution of METARs over the United States. We can click on this map and it can zoom us in a little bit, and just, you click on the location so you can get this populated with more METARs. Kind of a neat site just to look at the current METARs get across the country. METARs, these surface, we used to call them SAOs in the old days, surface aviation observations, and they went to this METAR system. They're basically used primarily, not for numerical weather prediction, but for aircraft, right? For pilots needing to know what are the conditions at the airport they're about to land or take off from, get the altimeter setting, get things set up before they take off. But they're obviously part of the global data network and get ingested into models, particularly short-range models for weather. And so METARs, there's a standard reporting structure for the U.S. and globally. Different countries have slightly different reporting processes. We report things in the U.S. in degrees Fahrenheit, which gives us a little bit more granularity in our temperature observations. The rest of the world does things in Celsius, and so we don't get that level of detail. But what I wanted to show you is that during times of conflict globally, we can see degradations into our network. So we're going to go across the Atlantic into Europe, particularly Eastern Europe, and you notice a conspicuous lack of observations over this part of the world, which is where the Ukraine is. So one of this airport near, I'm not sure how to pronounce it, Lviv airport is reporting still in western Ukraine. There's a vast area in which data is not being reported. Whether it's actually being collected, I don't know, but that's certainly going to put a hole in the data network over parts of Eastern Europe.
Previously, how many METARs were there?
I think that's an excellent question. We can go back in time. I don't know how far back we can go on this. I don't think we can just go back from today. But I would imagine that the density of these would be kind of similar to what you've seen in parts of Poland and other areas. So more than two, certainly. Their airports, Kyiv, is not reporting, and that would certainly show up on this map. That's unfortunate. Not just for the loss of data, but certainly loss of lives that are occurring in that conflict. So that's interesting. Another thing that's appeared in the last couple of days, which I don't have, it's not war related. It is related to the lack of helium globally in its production. And so there are a number of upper air sites in the United States that are now curtailing the release of balloons for soundings because the weather service offices that are releasing the soundings don't have sufficient helium. So they're reserving it for critical times when they think they need to take the data. And so we're going to see that's another issue of supply chain things and just how we do this globally. I think actually a supplier of this helium that's in Russia, they had a fire at their station, something unrelated to any of the conflict, and then also, but also I guess trade embargoes are going to not allow us to get helium from those sections of the world.
Is that where most of the helium comes from?
I don't know, but it's certainly for some globally, there's not much production in helium just globally anyway, and so having any
This is before the war.
This is before, right?
Yeah.
There was some discussion on the map mailing list the last day or two about that.
Yeah. So upper air soundings are being curtailed, and people are now beginning to think, well, what are other options beyond the soundings? They could use hydrogen, but not all weather service offices are secure enough to use hydrogen. So there's really interesting aspects on how things in the global supply chain or conflicts can interrupt data coming from different parts of the world, including the U.S. So let's now take a quick look, next tab, on just upcoming hazards. It's a pretty quiet time across much of the United States, at least in the medium range. These are the 3 to 7 day hazards that are shown right here. Here's the legend down here with the risk of some high winds over the northern and central plains, extending down to North Texas. Maybe some really chilly times over parts of southern Alaska. And then risk for some snows in the northern parts of the Rocky Mountains. And some heavy precipitation. I think any precipitation would be appreciated over parts of the Washington, Oregon, and Northern California parts of the United States. So that's coming up in the short range. Go to the next tab. Just looking a little bit beyond this. This is from the CPC, the Climate Prediction Center, and they do forecast in groups of sort of average forecasts. These are looking at seasonal forecasts, and I thought it might be interesting to begin looking at and anticipating what's coming up for this upcoming summer. Let's just skip over spring, even though we're early into it, and look at the June, July, August period. We can look at other periods as well, but we'll first look at precipitation. Now these 3, we're not going to click on data, but either E1, E2, E3, and they do these 10-day periods in which they take output from the climate forecast system version 2. It's a global model, much like our global GFS model, but it's run in a climate mode, so it goes much longer, and they integrate it out. And they sort of average the forecast. These are going out to June, July, August, so they're running this out at probably fairly coarse resolution, but they average those 10-day those forecasts initialized over a 10-day period for the June, July, August period, and then collect them to come up with a forecast, an outlook for precipitation anomalies. And if we click on this particular map, this is June, July, August, as an example, you can see that they have a good portion of the western United States down through the central and southern plains, and parts of the southeast as being dry. In the upper Midwest, at least in terms of their precipitation anomalies, but also showing up as relatively dry. So these are forecasts that were initialized from initial conditions from the 9th of February to the 18th of February. Let's go back a click. Let me see if I can't recall which one you clicked on.
That was June, July, August.
No, but if you go back another click, E3 is the more recent.
That was E1.
Right, so we look at E3 for precipitation, and June, July, August. So it's for the same period. Again, there's some differences here, but again, this isn't good for parts of the central part of the United States because of, they're already been dry over the last several months, and it's going to just intensify the dry conditions over the central United States. Again, Wisconsin being kind of in this, the precipitation anomaly not being particularly strong, positive or negative over us. So we can imagine, without even looking at it, but if it's going to be dry in these regions, and we know what the climatological flow is over these regions, we might expect it's also going to be above normal, perhaps. Let's take a look at the temperature anomalies, the 2-year temperature anomaly for that same period, E3. Yeah, look at E3. And sure enough, with dry soil conditions, all the solar radiation impacting the surface is going to go to desiccating crops, but also the dry soil. It's going to just heat up the soil. And then from that, air in direct contact with the soil is going to then get mixed. You're going to get an area which is going to be much warmer than normal anticipated. Again, these anomalies are relative to the 30-year average, right? We talk about anomalies climatologically, it's based on a 30-year average. I think this would be from, 1980 to 2010, I think is the period we're using right now. And so any forecast above normal, given the trend in climate, has been for things to stay above normal. So when we're seeing these above normal, temperatures like this, that's probably even already building in what's happened relative to our long-term climate trends. So above normal is at least a forecast one might make based on the dynamical models. Let's go back a click. I've jumped all the way to the summer. We can also just look at our upcoming spring. We're halfway through March. Let's take a quick look at this for temperature anomalies. Again, from these dynamical models, they're putting us in a regime which is going to be probably relatively close to normal. the southern part of the United States being above normal temperature-wise, and chillier over the Pacific Northwest. Finally, to go back and look at precipitation for March, April, May. This is one bit of good news if it were to verify. And we've been pretty dry the last several months. Most of the winter has been dry. This is forecasting above normal precipitation for the northeastern and central part of the United States. We got dry over the southern part of the United States. So for us, maybe a little bit of relief going into our growing season. But for the southern part of the United States, this does not look good. Yeah.
Do you have any clue on how unusual this is for that dry? I mean, that looks like it's going all the way to the end on their list. I don't know. I don't know how to take this. You know, I mean, I don't know how accurate this is or how unusual that is.
I don't have a sense of how unusual it is. I mean, being this dry and it's been, it's sort of persisting the drought. And I don't know the verification statistics for this particular model, which is really an important thing. But we could take what we've seen for the summer and for the spring and for the summer, and let's go back to that first tab for a second. When they make seasonal forecasts or sub-seasonal forecasts, they don't just use dynamical models, because you know we can't just turn a knob, run a model all the way out, and just believe the output explicitly. They have other statistical guidance that they use. And I think we can come over here and let's go down scroll down a little bit on this side. Can we scroll down here? Can you click on some part of that? Or?
Apparently not.
Maybe reload it or something? I don't know why it's not. That's really weird. What I was going to show was the forecast. That's weird. The forecast for, if you look at the actual Climate Prediction Center's forecast for this period, doesn't explicitly look just like this, the forecast that we see. That doesn't go far enough out, I don't think, for seasonal, but we can try that. I'm not sure why this isn't working. But Greg's question is really a good one. How unusual is this forecast? It also brings up the question, is this a reasonable CPC outlook? I think that only does the short-term outlook, so this is pretty good. When they make a forecast, they look at other things beyond just a dynamical model. They have a pretty good sense of what they're looking at. I'll find it for after weather, at a later time, I'll send a link. Or we'll look at that forecast from CPC for the longer term. For some reason, it's not showing up here.
Is this what we'd expect? I know we're in a La Nina,
right.
and I think it's forecasted to get a little bit weaker, but still stay somewhat negative. Is this a pattern that we expect to see in the summer months?
If it were to persist, I think the dryness would consider, and we can go back to that.
I can get to it. I think I zoomed in.
Oh, maybe it was just zoomed out. Okay. So, seasonal, we have our sub-seasonal. Click on their forecast. Or actually, let's go to their home. Okay, and they show seasonal 3-month outlook here. Click on that. So this is March, April, May. We're looking at for temperatures and above normal in the southern part of the United States. This looks a little bit like what we saw in the dynamical forecast for the same period. And I think they have one for June, July, August as well. They should have it. Nope, not showing up. But keeping it dry here, they do have it a little bit wet over the parts of the Ohio Valley, Tennessee now. Let's go to that CFS2 link right here and go back a click and look at SST's forecasted. We can look at I'll go monthly. Let's just do monthly. And E3, sorry. So there's been talk about La Nina. I'm not an expert on that, but by any stretch, but a lot of news in the last several weeks, I think there was an anticipation that this was going to begin to weaken somewhat but more recent models are now suggesting, this is a whole collection, ensemble of forecasts for SST anomalies in the Pacific have been trending downward, so keeping things colder than normal over the equatorial Pacific. There's a set of maps that goes along with this that just shows the global tropical Pacific temperature distribution, sea surface temperature distribution, and it shows a very prominent cold temperature anomaly that persists all the way through September. So La Nina is expected. The impact of that on the hurricane season in the Atlantic, typically with a strong La Nina, I think is for weak and shear over the main development region, so that's conducive for a pretty active season, at least one factor that can contribute to an active season with weak or shear. Okay, so we'll move on to the next tab. Satellite imagery, visible satellite imagery from this morning to current times. And, you know, two areas of really active weather, or probably three. One over the southeastern United States, we'll see this is associated with thunderstorms, a line of thunderstorms that's developed along an old front. You'll probably see sort of some evidence of an older cold front. Another boundary that just passed through us in the last hour or so that left a little bit of light snow and snow showers over us. And then a more prominent band of cloudiness that extends all the way into southern Canada, or southeastern Canada, down into to North Texas. And there's precipitation along this front, well behind the front, actually. The surface front itself is a little bit further ahead. We'll see that one with the surface map. But behind it, a lot of clouds and then a band of precipitation. This whole weather system is expected to migrate eastward over the next 24 to 36 hours and produce a modest snowfall event for parts of the from northern Alabama and Georgia all the way up into the northeastern United States. But it's not expected to be a blockbuster storm. Interestingly enough, and I don't know the history of this, but we could talk about it, or the history of the model, how this model works, but there's a version of the NAM, 3-kilometer NAM model, the North American model that's running. It actually develops, has a sea level pressure minimum that gets into the 930s in the Gulf of Maine, but I think that's just something spurious with how it's working, but it's doing some really weird things with this particular weather system, maybe near the edge of the domain. We'll look at that. But that's going to be a factor we'll look at in the forecast. The other thing you can note is these areas here, as the clouds progress, you can see the snow from earlier in the week, in the last couple weeks, well to our south. So you can see these tracts of snow that exist well to our southeast, and then over the parts of the Rocky Mountains, snow-capped Rocky Mountains, the snow shows up pretty well.
One question, do you know what the final measurement was on the snow we had?
For the airport, no, I don't. Does anyone know that number for the airport? We can maybe go to Milwaukee, MKX NOAA, and take a quick look at the final report.
That was our biggest snow of the year.
Right, 4 to 5 inches, but how much did we get? Drought information. If we go back, actually, would Ed Hopkins' page have it, if it's updated?
It is updated, and it probably could guess from.
I think I saw something like 4.5, 4.7 on nebula.
It's like roughly 4.
Yeah.
Right there, about 4.
So that wasn't the biggest, because there's another bigger one.
Right, there's a bigger, it's about 6 or so.
So that was technically the approximate point.
Oh, okay, so it's two.
Oh, yeah, you can see that, good point. So, in a single event for the season, that was a pretty decent
Still
one.
well below normal.
Right. Okay. And, yeah, our total stuff is above normal, or below normal. Okay. So we'll just keep going across. This is here's the radar that shows those areas, that area of connection to the south of the thunderstorms. We'll look at the lightning strikes in just a moment, but you can see this band of precipitation along with Florida, the northern part of the Florida Peninsula. Here's this area of fairly light precipitation that extends along that front and north of it. And then finally, this band of precipitation, we'll see when we look at the Alps, is associated with a weak, a dry front that's passed through our area, but a weak frontogenesis along it. You can see the band of precipitation associated with it. So, again, I'll say relatively quiet across the United States. Maybe the most active area, or interesting area right now is just over the Florida Panhandle. So let's take a look at that. Pete with the lightning, that's the next tab, I think. And there you can see this is over the last about 5 hours or so. You can see the lightning progressing offshore from the lightning detection network. A little bit of lightning to the east of the Dallas-Fort Worth area, as well for that area of precipitation that we saw there. Again, pretty quiet map right now. Let's continue. If there are questions, we'll go to the surface map. I don't think I have that set up just yet. So look at our surface map. Large format, we'll start over our area. Last hour 27/6 with a westerly wind. You can see the front has passed through our area. Right, pressures have already started to go up. It's approaching the Milwaukee area. Nice wind shift across it, and then temperatures drop off significantly. 27 here, so you get to this near La Crosse and 21, and then into parts of central Minnesota, getting 8, -6. So low wind chills, low temperatures. What is this? Bemidji, right? So 1 degree. It's Brainerd at 8. So it's pretty cold behind this front. Maybe, hopefully, fingers crossed, the biggest, the last big chill of the season as this front
A
moves.
couple of negative zeros up here.
Right. Just slightly below 0 to the north. See, these are the benefits of using things in degrees Celsius. You can actually hit negative zeros and not just. Although I guess you could probably put the decimal point up here, right? Will that work on your software feed?
I don't know.
Like -0.3 or something like that. So in degrees Fahrenheit, we can do that nicely. But again, we can see the evidence of a weak front with a nice trough wind shift associated with that. Let's go to the southeastern United States. And across Florida, we can see another boundary here. There's certainly a wind shift with winds broadly out of the south on this side of the boundary, out of the east and northeast, the northern part of that boundary, and you can see the precipitation right along it. So an active frontal boundary that exists right here, certainly a trough with a wind shift associated with it, and the precipitation. None of these stations reporting actual lightning or thunder, but we saw evidence of that in the lightning detection network. Moderate rain near Jacksonville at 67/65. If we go further to the east, or west, excuse me, we can see over parts of North Texas, strong winds out of the north. They would call this a blue norther, as the textbooks of old used to refer to it. But northerly winds here, 28, 26. I guess this is what Amarillo. Midlands down here, I think, at 32. Full advection, but you can see again some light snow here. Also in southeastern New Mexico, a little bit of light snow. And then along and north of this front, the surface front as well to the east here, you can see the cold advection extends all the way back into parts of Oklahoma. This light snow that extends, even moderate snow on the north of Arkansas this morning. So that's really kind of interesting with the surface fronts right here. But we know that front has a tilt, that frontal surface tilts upward with height, right? Kind of like that. And it's a pretty shallow wedge of cold air. And here's where the precipitation is occurring. You'll note when we look at these maps right here, winds are generally out of the north. When we go up a little bit to 850 millibars as an example, we'll see that the wind shift is, the winds are more out of the southeast at this level. So it's overriding the front. So this is, just looking at the surface map, it's not going to give you a good sense of where is the air that's producing the precipitation coming from. It's actually at a much higher level above the front as it glides over the front and ascends. Okay. Now let's just go to the northeastern part of the United States for a second, or mid-Atlantic, further to the east. And then over here, where they're about to get perhaps a modest or moderate amount of snow, in temperatures today in the 50s, Harrisburg at 54, Albany at 41. So these are places that are expecting rain and then a change over to snow. Up into Vermont, 43 over 29. These are places that might be seeing, 6 to maybe 8 inches of snow over the next 24 hours or so. Pretty mild, even along the, apart from Massachusetts coast, where they may see a very quick change over from rain to snow. Temperatures in the 40s and the 50s. I like this type of weather this time of year. Much as I complain about snow, I love seeing situations in which it's nice and mild, and then the next day, 24 hours later, lots of snow, and then hearing people grumble, I didn't know that was going to happen. Well, folks in this room and others know that that happens, so I take pleasure in that. Not people's pain, but just the fact that it's, we can forecast and we have a sense of what's happening. All right, so that's the surface. Let's now move to the superheat maps. And we'll start at 500 hectopascal, please. And so at 500 hectopascal, we can see a broad southwesterly flow. We can see one trough. This is the one that's sort of associated with, that gave us, just ahead of it earlier this morning, gave us the snow showers just an hour or so ago. Okay, so it's a nice curvature to it, not much of a, going from cyclonic to anticyclonically curved, but cyclonically curved to nearly straight. So there's a little bit of divergence you might diagnose through the changing curvature just on the southeastern bit of that. Another trough that's out over the southwestern part of the United States, but a fairly uniform flow from the southwest to the mid-Atlantic.
In the curvature area, it's interesting that the isotherms are almost parallel to the isobars.
Right, so not
Which
much.
means the air really is curving.
It's really curving because
Yeah.
it's following right along the flow, so there's very little temperature affection there. Let's go down to 850 hectopascal, and this is where you'll see the comment I made about the winds being out of the southeast. Now, we saw these basically northwesterly winds through here, but you can see at Dallas, Fort Worth, there's a southerly wind right here. But there is some weak frontogenesis along this boundary, and with that frontogenesis occurring, we have that soreal eastern circulation you might be able to diagnose, and that's giving you that ascending air. Dew point depressions are relatively small, so you lift it up, you're going to get some precipitation, but they're not zero, so it's not heavy precipitation in that sense. Along the southeast part of the United States, where we saw the surface front, I guess that frontogenesis and the frontal circulation is a bit more shallower down here. You don't see really much. You can see some baroclinicity here, but you don't see the abrupt wind shifts that we see closer to this main baroclinicity. So this is really where the action is, and we're going to get the interaction of this upper trough that had its origins a few days ago in northern Canada. It's been dropping southward. It's going to interact with this trough and sort of energize this front to produce a band of modest precipitation again from southeastern United States all the way to the northeast. You can see that in the forecast. Okay, let's go up again to 300 hectopascal. We'll see two, I think, distinct jets. Here's our subtropical jet moving across Mexico into the northern Gulf of Mexico, and then we have the polar jet. I think this will be a fair delineation of it. You can see the jet maximum located over Alberta, directed into Wyoming, and then another piece of the polar jet from Kansas all the way into the Canadian Maritimes and then out to the Atlantic. So pretty nice trough associated with it. Again, the change in curvature here is much weaker than we saw at 500 millibars for the trough over the upper Midwest. And so at this point, it's not particularly, in my mind, a particularly interesting map at this point. But comments certainly welcome before we go into look at the forecast.
And Michael,
Yeah.
do you have any suspicion of this northerly jet intensifying in the coming hours? I can't quite see the thickness lines on there. I was wondering if you could.
Yeah, it's hard to see if we're going to get much in the development of this. The temperature advection along the jet, at least at this level, maybe we've got a 400 millibar since we have that map. We've got a better sense of it. So what you would like to see if this is going to be an intensifying jet is you'd like to see cold advection on the cyclonic shear side of the jet, which would force subsidence and help to intensify the tropopause folding in this region. And it seems like, as Greg had noted earlier, that much of the temperature advection is pretty weak here. The winds are nearly parallel to the isotherms, and I don't get a sense that this is something that's going to really amplify much. And I don't know if other folks would diagnose the same thing, but that's my sense on this. That not obviously any strong cold advection or warm advection. Should it do the reverse of that, at least at this particular time. Okay, so let's go on to our next tab, please. We'll come back to that. This is, excuse me, the outlook for tomorrow. We'll come back to that. I don't want to go to this tab just yet. I'll go to our meteorograms. First of all, for Madison, you can see we were expecting sort of max out temperature-wise around noon, and then things beginning to drop. Also note, set your clocks ahead on Sunday evening, so, or Sunday morning, Saturday evening, yeah, Saturday, gosh. Don't listen to me, just set your clocks at the right time. Temperatures maxing out early in the afternoon, then just dropping. And we saw evidence of that. The cold front has already passed through the area. Temperatures are basically, they've reached their maximum for the day. They go just 1 or 2 more degrees, but then cold advection is going to sort of overwhelm that. We dry out, but then bottom out tomorrow morning, and then we have a nice beginning to a warm up. Tomorrow will still be chilly, but Sunday will be a little bit warmer. And with that increasing temperatures, we have a chance of either rain or snow, depending on what the temperature structure is. We'll see why that's the case when we look at the next map. So we'll go to the time height section, so you can take a look at that. So here's our time height section. That upper trough that we were talking about earlier, that was over the International Falls, northern parts of Minnesota. As it passes east and southeastward, goes by us, you can see here's the dynamical tropopause. Those of you at 311, you're talking about vorticity and potential vorticity. Here's the 1.5 PV isotel, which is used to denote, define the dynamical tropopause. 1.52 PV works pretty well. You can see beneath this localized maximum potential vorticity, all the values are higher above here. You notice this cold dome of air beneath it, and temperatures a little bit warmer above. And so this is the characteristic temperature structure you might see with a PV undulation. So, you know, this is the cold air beneath this, the upper trough as it begins to go by us. At the surface, we can see our westerly winds, early it's going southwesterly, the winds becoming westerly, then northwesterly as the cold advection takes over. And you can see with these isotherms sort of steepening here, this is the arrival of this colder air beneath the upper trough. Bottom out tonight or tomorrow morning, and then we can see a gradual warm advection as these winds, if you assume that they're nearly geostrophic, varying with time, or varying with height, with warm advection occurring, and you can see these isotropes beginning to lift or recede, come back down as we begin to warm up. At some point, you can see intense warm advection here with the winds veering, and that's associated with this ascent that's going to be arriving late tomorrow night. This is late Saturday night, early Sunday morning. The column, strong vertical motions, the relative humidity is beginning to increase with that, you know, as the air rises and reaches its saturation point. Clouds, and this is the light precipitation that we might anticipate early on Sunday morning. And then the winds become more westerly and things begin to dry out as we warm up as well. So a little bit of precip possibly, but it's a warmer time to have a really strong warm advection. And look at this winds changing from southwesterly to more west-northwesterly in the lower troposphere early Sunday morning. So this is midnight tonight. This is 1 a.m. Sunday morning. Okay. So let's take a look at the maps and see what's actually happening. We'll first look at the 6-hour forecast here at the surface. Again, this picks out kind of the key features, the key precipitation structures we saw in the forecast. This is the accumulated precipitation over the last 6 hours. That convective precipitation along the Florida Panhandle shows up nicely there. Precipitation we saw in Texas and parts of Oklahoma shows up nicely. And we have very light precip over us. Here's the frontal trough right here. This is just a band of precipitation ahead of the front. I don't think we saw much on the radar necessarily in that particular region. But you can also see the really cold, very low thicknesses associated with this upper trough as it arrives. But there's the nice frontal kink right here in the isomers that went to our area. It will be going to our area. It's already gone to our area at this point. Let's go ahead 6 hours, or 12 hours, excuse me, to so as that upper trough continues moving east-southeastward, begins to interact with the barochronicity over the eastern part of the United States. This front begins to get a little bit more active. A lot of the precipitation is post-frontal. Here's the front, but you can see a band of pretty moderate precipitation. This is cold enough for snow. Again, it's going to be cold enough for snow in parts of Arkansas, Mississippi, and Alabama, and perhaps northwestern Georgia before this is over. So this is midnight tonight. This band of snowfall in places that were in the 50s and 40s and 50s today are going to be about to cool off and get some frozen precipitation. For us, the part of the cold air is just about over us. We'll wait till tomorrow morning as we bottom out, but then things, you can see the warm convection on the western side of this ridge begins to ramp up. Next, we'll go to the middle of the day tomorrow, so 30 hours, excuse me. As that trough, again, interacts with the baroclinic zone, you're getting a nice burst of precipitation from the Carolinas into the northeastern part of the United States. Right, this low is 988. We'll look at it in a couple of the other forecasts, but it's a pretty decent storm, but it's really not a well wound up storm, right? It's not a nice circular set of isobars. It's pretty stretched out along the front. Most of this is going to be associated with frontogenesis for the precipitation, the mechanism of producing precipitation. Some lake effect snow, Lake Michigan, and again, the warm advection beginning to start up to our west. Here's the next little Clipper-like system that can give us a little bit of light snow tomorrow evening. So another 12 hours ahead, please keep. And so with that strong warm advection, lower tropospheric warm advection, we're getting ascent, and here's our precipitation maximum as it goes by. This weather system is now off the East Coast. It gets down into the low 960s, or upper 950s in this particular forecast. But it's pretty much over for the eastern part of the United States. But here's our light snow, and then the warm-up begins right after. So let's go to 54 hours, midday on Sunday. So midday on Sunday, our Clipper system is still heading out of the area. The warm advection, the maximum warm advection is now over Michigan and parts of southwestern Ontario, and we're just in this westerly flow. Higher thicknesses, and again, warmer times after that. What's it look like in terms of potential vorticity? We can look at the 310-layer potential vorticity. We just moved it 305 to 315. And if you recall earlier in the semester, we were looking at the dynamical tropopause is in this transition from green to blue, so that's the 1.5 potential vorticity surface. We had these higher values much further to the south on this isotropic surface. It's now beginning to retreat. And when we begin to get into these areas of low PV coming in off the Pacific, particularly with the westerly flow, that pretends that we're going to basically begin to have much milder weather. So at the beginning of this pattern, we see the deep trough over us. That's introducing the cold air over us, that rapidly moves eastward. Dynamical tropopause lifts, and we begin to get into this more Pacific air mass on this isotropic surface with a higher dynamical tropopause. That's going to be much milder weather for us. For the East Coast, another sign that this doesn't really become a truly massive storm is the fact that we don't see this PV trough really beginning to wrap up significantly, which would be another signature that would lead to a nice set of round isobars associated with the developing cyclone. We do see evidence for late heat release as PV begins to get generated along this isotropic surface just off the mid-Atlantic coast as its low-level wave begins to develop. If we could stop this and go to a individual map, let's go to 30 hours this level. So this area of higher PV surrounded, we can't explain let's go back to 24 hours and then just step ahead so you can see it. One of the rules, if you will, for potential vorticity is that on an isotropic surface, it's going to be conserved, which means you should be able to explain what you see on one PV map from one time to a later time simply by advection if the flow is adiabatic and indicent. So this structure right here, it does actually show up at this time, so I'll take back what I said earlier. This structure already exists in this level, and if we go ahead 6 hours, we should see this basically be advected further to the northeast. So I didn't pick up on this. There's that structure right there. Anything else that basically appears on this map that we can't explain by advection is going to be something that indicates the role of diabatic heating. I would suspect that this piece that we see here, we saw it earlier, further to the southwest, probably had its origins from latent heating along the front earlier, and we can go back and check that, but let's go ahead another 6 hours, just to play this out. And that piece actually nicely, I think, ends up, maybe it's a little bit larger, so that indicates, you can see the area that's encompassed by this higher values of potential vorticity compared to the surroundings. This is a little bit larger, and this may be associated with significant latent heating, helping to expand and grow this area. But you could track it nicely over that 12-hour period ahead of the upper trough, so it's something a little bit separate from that. But it's going to be associated, if we were to invert this, with a lower tropospheric cyclonic circulation. So east of Maine, let's just go back a click and look at the surface map at this time at 36 hours. Okay, so east of Maine, so that's a PV that's associated with this really, with the surface cyclone that's positioned in this location, but also the precipitation in that region. All right. And then finally, we'll just go to the look at the Q vectors for tomorrow at 30 hours, as this front's moving to the East Coast. We can see this is what's plotted here are a layer average quasi-isotropic Q vectors that are plotted here. Convergence of Q basically gives us a diagnostic, or is a diagnostic for ascent. The fact that these Q vectors are directed from cold to warm gives the sense that this is a frontally active situation, with frontogenesis occurring. But convergence of Q is going to be a diagnostic for ascent broadly in this region where we see the heavy precipitation. So it's a nice, quick and dirty diagnostic for precipitation. At the same time, we see convergence of Q along this thermal ridge, or just ahead of this thermal ridge, which indicates, again, that's the area of ascent that's going to come over us tomorrow evening, 12 hours after this time, to produce some precipitation, or light precipitation. So let's go to pivotal now, if there are any questions about this, and take a look at just another look at the forecast from the GFS. And we'll start at 18 hours into the forecast. We'll just jump ahead a little bit in this, so midnight tonight. And this forecast, again, we have a cold advection over us. Again, these are really low thicknesses for pretty much any time of the year, but that's definitely cold advection over us. Here's this wave that's developing over the southeastern part of the United States. You can see the extensive area of precipitation, snowfall ahead of that. We'll go ahead to tomorrow morning, 24 hours. Here's the cyclone, hasn't really deepened appreciably, but a lot of convection associated with it, and again, moderate snowfall rates expected sort of west of the I-95 corridor. So these are places, I mentioned Gaithersburg earlier, probably get some snow and freezing precipitation west of the line from basically Baltimore, Washington, heavy, moderate to heavy snow briefly, if this forecast verifies, and all the way up into central and northeastern Pennsylvania. If we go ahead another 12 hours to 0Z, you can see, again, that cold advection has rapidly spread to the East Coast. It's going to get chilly there, and here's the big warm-up for us. If we go finally 6 hours ahead, we're looking at the possibility of snow over us with that strong low-level warm advection. There's the warm advection, winds directed from higher thicknesses toward lower one. We can see broad area precipitation. And it's really just a function of how moist is this air, how quickly can we lift it up and produce precipitation. But this is suggestive of some snowfall over us. The thing that I want to just look at, and maybe Greg can comment on, is in the forecast, if we look at a different model, go to the model, go to the 3-kilometer band. What do you make of this? Okay, maybe this is the edge of the domain or something. 918, we know that's not going to happen. I should say that. It's very unlikely that it's going to happen. But if we just go back, let's go back to 24 hours in the forecast. There's something bizarre. This has happened in a couple of forecast cycles. Okay, 991, that's not so bad. Although it's kind of an odd cyclone well ahead of the front. There's more of a surface trough there. There's 986 a little bit later.
Is that the actual edge of the domain?
There's the edge of the domain right here.
Wow.
You expect that to be forcing something, but this is This is a bit inland. You don't normally see this. I don't look at the,
My question is, why do we look at the NAM at all? What
So
is
it's
its
its value?
value? I don't see
its
it.
value, I think, for the reason NOAA runs it, the National Weather Service is interested in running it, is because it gives a quick look before they have the GFS out. But the question is, it doesn't do weird things like this all the time.
It's prone to it.
It's because of,
I can't see how let's say, a 6-hour or 12-hour GFS forecast is superior to a 6-hour, a greater, like an 18-hour GFS,
oh, sorry, 6-hour or
You
12-hour
have a forecast at this time.
Right, you already have $1.
You already have one, and the previous GFS, I think it's gotta be better. Even the ECMWF has almost as half the resolution of the, I don't see why we're using limited area models in 2022 for this kind of thing. It just seems absurd to me.
I think part of it is that they're forecast consumers that want to have as early a look at a forecast. Whether there's value to it is a whole different story. But they want to see a quick look at what the forecast is going to be at a higher resolution, higher granularity.
And it's
that you get
misleading.
difference.
If it's different than it was in the previous few hours, it tends to be misleading.
Right, but this is just more just an issue with the model itself. What's happening with this? You got 981.
It's probably some boundary condition problem, mismatch with what the GFS is.
Right, so if we go to GFS, because that, I think it does use the outer PC version of the NAM, GFS at the same time. It's still pretty close at this point, but then it just goes berserk if you go to the GFS. Now it's-
When I look at what's actually happening there,
Mhm.
it's again the intersection with the polar night jet and the acceleration of flow law. It's going out the boundary. I don't know what the NMM is doing with that. I think, I just really don't like the NMM. I mean, it's an okay model for doing the analysis and
Right.
the grid somewhere, but in a forecast mode, I just think it's misleading. It's a waste of computer time. You'd better off to make another member of the GFS ensemble than they would doing this stupid thing.
Perhaps,
Is
yeah.
the domain different between the 2-kilometer then and or is it just the projection?
I think it's different. I don't think the 2-kilometer is as big.
Right, so this is at 964. Let's go to the NAM. I don't want to keep liking through the,
Mhm.
we can count isobars, but I don't want to do that. 86, these are every 2, so again, also contour every 4 hectopascals, not doing silly like this, but we have, that's 4, that's 8, 12, 16, so we're at 970. This is the 960, definitely at that point. I don't think we'll get too much. Yeah, it doesn't go far on these. Anyway, this is a weird aspect of what's going on near the boundary for this particular, the 3-kilometer dam. When getting down to 914 is just bizarre. But that could be, as Greg was saying, just an issue with the boundary condition.
I think another thing to be aware of is when you're predicting precipitation,
Yep.
it's not obvious that a 6-hour forecast for a given time is better than a 12-hour forecast for a given time.
That's a spin-up issue, right?
Well, it's a setup issue. It's the fact that we don't have enough observations to refine the vapor structure in the atmosphere. We have, 400-kilometer space, and we have some observations. We do a simulation, but the observations tend to blur the actual crispness of the water vapor structure. And the result is that you get the best forecast, probably 12 to 18 hours for precipitation, and then it starts to get worse. Unless you miss something really, really important, then possibly it could get better. But I don't think it's automatically better with a 6-hour forecast than a 12-hour forecast for the same time.
But isn't the other issue, another part of it, not just the water vapor, but having fully resolved 3D wind structure?
Yeah, that's right.
Because you don't have.
You have it because we're assimilating this data now. We're not doing a raw analysis.
Right.
We're assimilating it, but we tend to break up a little bit the previous forecast we had based on the error. It takes a little time to recover. So that's another problem, right? I mean, the recovery time of the forecast before it gets rid of all the nonsense that's in there. But it's pretty good nowadays, the beginning. But I think the vapor structure is just something that is probably better in the forecast. And it tends to be mucked up a little bit. You tend to get bigger, blurrier forecasts of precipitation in the first couple hours, while it's trying to do a frontogenesis or whatever you want to call it to refine the structure of the precipitation or the vapor to the atmosphere.
There's actually a project that Noah and I are working on with Sam Steckman and Leslie Smith and Matt about looking at how moisture gets analyzed in models and this notion of balanced moisture. They've done some work on that in that space. So can you improve the assimilation of moisture by trying to get something that's more balanced at the initial level? So that might help lend some support for how to improve these forecasts. But if we go back to the GFS and away from these boundary issues and just look ahead to, we'll go to 96 hours. We'll just click quickly ahead every 24 hours. You can see, well, Tuesday, unfortunately, another ridge comes in, so we cool off after a brief warm-up. But we'll go ahead and see that we don't have too bad a week coming up if you stay in the Madison area. Again, this is going to be a nice day on Wednesday. Go to Thursday, still pretty decent. We'll front just to our west at that point. And then a wet Friday, unfortunately. Earlier in the week, this cyclone or something like it was going to produce up to 7 inches of snow on Thursday and Friday, but looks like we just get a nice chilly rain on that day. Saturday, and then going into the weekend, cool. We can go to 201 hours, right? The sun's still going to be up, and go to the temperatures. Just to get a sense of next year. So this is 21Z. That's now 5 o'clock in the afternoon. In the 40s, not too bad, but certainly like warmer weather than that. But it looks like the cold air stays toward north at least for most of next week. The really cold air is going to be well to the north. I guess that's really where I'm going to wrap things up. We can go ahead a little bit further into when we return to classes. You can just keep clicking ahead. We cool off, but not super cold. So that's not pleasant for okay. Well, thanks, Pete. Thanks, everyone. Just a brief summary. Snow showers we had this morning are pretty much over. It's going to get windier, cooler this afternoon, colder this afternoon. Tomorrow will be nice or nicer. Then we have a brief period of light snow or rain on early Sunday morning, as we set our clocks ahead, and then we warm up for the first couple days of next week, then cool off Tuesday, Wednesday, warm up again. But not super cold. It'll be a much nicer week than this past week. Anyway, have a safe spring break, and see you in 2 weeks. Thank you, Pete. Thanks for the comments and questions. If you like this broadcast, for those of you on YouTube, please hit subscribe. Click the bell so you never miss an episode.
Notifications on.
Yeah, right.